So total solidification time on y-axis we are representing temperature, on x-axis is time. This temperature is called as pouring temperature. This one is your melting point temperature. The time required for solidification from state A to state C is called as total solidification time. Basically this problem is based on that we have a particular casting arrangement here having a certain thickness. So the body is three-dimensional body and this body at a particular temperature is at T1. So pouring temperature is what? T1 and this temperature equal to what? The melting point is what? T2. So this body has a certain volume, certain area, has a certain density, specific heat and thermal conductivity. Outside is cold air, suppose, then if the heat is transferred, in that case we can say the rate of change of internal energy must equal to what? The amount of heat transfer. So rate of heat transfer is area. Is it a surface area? Surface area. That area which is in communication with surrounding air multiplied by heat transfer multiplied by change in temperature, that is delta T, must equals to the rate of change of internal energy is given by mass multiplied by specific heat multiplied by rate of change of temperature with respect to time, and mass is defined as density multiplied by volume. Now out of this the physical properties are physical property. Either density is a physical property, Cp is a physical property, thermal conductivity is a physical property. Now whether I have this type of shape or I have very flat surface of the same volume. Now this has a very large surface area, so the rate of heat transfer is high, rate of heat transfer is low. So is the basic criteria for this one is area or is a volume? Area. Larger the area, larger the heat transfer, smaller is the time. It means that if you want more TST, then the surface area required should be small. If you do not want to solidify the metal in riser, what is riser? Riser will feed the molten metal to the cavity when the solidification has started, that is after this time, from here to here it will shrink. Is that correct? For this one to this one we have riser and this one is our allowances. So what we want is that the TST of the riser should be more than the TST of what? Casting. For that purpose is the area for heat transfer should be as small as possible. The area should, if area is minimum, the heat transfer rate is also minimum. If the heat transfer rate is minimum, then naturally it will take long time to cool down. So what is this factor comes? We can solve this equation. We have done this in heat transfer. Using the same idea, this fellow, that is a Chvorinov fellow, has given the equation almost same form. So the TST, total solidification time, is equal to K times V by A to the power n. V is the volume and A is the surface area and N is constant. So he has basically taken the same equation. That is all these values are, he has taken same. And then he has used the constant n. So is that constant n is entirely dependent on physical property. Okay, I will write this equation as this one is As H. Remember this is called as excess temperature theta in heat transfer is M multiplied by Cp. This one is also called as excess temperature. Then we have separate the variable and then we have got d theta by theta. Recall this. Then we have As multiplied by H divided by M multiplied by Cp multiplied by dt. We integrate this and we get the log term. Remember that? So we have ln of theta 2 by theta 1. So that depends on this property. The time is a strong function of this one. So H, what is S? Surface area, and M, is it a rho into V? So volume. That is why he has taken the same value. So this K will take care of all heat transfer problem. That is the density, Cp and K. So is the value of K is constant or value of K is variable? For material to material, the value of K will change because density will change, Cp will change, K will change. So you have to collect this data from data book. As far as gate is concerned, they will provide the constant. Now what volume? Is the volume here is represent the amount of internal energy. Mass, no? Mass is what? Density into volume. So what is the volume? Volume is basically the amount of heat content. So we are interested, what is the volume of heat content? What is the area? Is it any area or is it a heat transfer area? So we have a heat transfer area. And what conclusion we have drawn? If we want more TST, if we want TST should be more, then the surface area should be minimum. This conclusion you can draw from this as well as from the Chvorinov rule also. T area is large, area is small. If the area is small, will TST is more. Without changing the value of V and K, if you decrease the area, will the TSTs move? Suppose we have a cube like this, and instead of cube, if you make a rectangle like this, and the height is adjusted with the same volume, so the surface area is increased. To make a thin plate, surface area is very large. Naturally, you make a plate, your area will go like this. So the heat transfer is very high. So as far as riser, we want this type or we want this type? We want this type. The ratio of V by A is called as modulus, M. M stands for modulus. We will make it AS. So this one is V by AS. V is the volume and AS is the surface area. If the value of N is not given, you can take default value of N equals to 2. K is called as mole constant. It depends upon property for density, specific heat and thermal conductivity. So this value is variable, normally provided to you. If I use the constant equal to 2, suppose I use the constant here is equal to 2. So is this V by AS? Is it meter? V by AS, meter. Is it meter square? And this one is what? Second. So is unit of K. K is second per meter square. They can give you second per meter square. Sometimes they will express second per mm square and sometimes they can express it second per cm square. First case is cube of dimension equals to A by A by A. So volume of cube is A cube. Surface area is 6A square. In thermodynamics we call this one as characteristic length. LC, characteristic length. This time we will write simply V by A and we are calling is what? Modulus. So modulus term is same as characteristic length. So what is modulus? Modulus is V by AS. So again substitute this, we will get answer equals to what? A by 6. So modulus for cube is A by, and suppose we have a rectangular casting of the size equals to A by B by C. What we are assuming is that all surfaces are open to atmosphere. That is assumption. If any surface is not convecting the heat, you have to neglect that surface. So we have a cube here. So what is the volume of cube? Is it A multiplied by B multiplied by C? And surface area. Surface area is simply given by 2 times of AB plus BC plus CA. One area is this one, that is AB. Other area is BC. And one area is top area. So both are in reflection. So that's all. We can write M equal to simply V by AS. The third geometry is cylinder. Again all surfaces are open to atmosphere. We have a diameter equals to D and height equals to H. So the volume of cylinder is pi by 4 into D square into H. Surface area available for cylinder is circumferential area is pi dH and the heat is transferred from top surface as well as from bottom surface. So we have two circular area pi by 4 into D square. So modulus for this one is V by AS. So you have to simply put this value and you have to find out the answer. Now if I say that in a special case, if my special case is that the diameter is same as height, that is a special case. If diameter is same as height, can we reduce this equation? In that case, my numerator will become pi by 4 into D cube. D square H is same as D cube divided by, this one is pi dH. Pi dH is what? Pi D square. And 2 times pi D square is pi into D square. Pi by 2. This one is pi by 2 D square. Now you solve this. What you get to check out? Your final answer should come as D by 6. Now cylindrical risers are very commonly used. So always remember this value. M equal to what? D by 6. And finally we have a spherical object. So this one is the diameter of D is same as 2 times of radius. So volume of sphere is 4 by 3 pi r cube. Surface area is 4 pi r square. So what is the modulus? A is volume divided by, if you do this thing, we have done the same thing for heat transfer also, almost same. So if you substitute all this value, what do you get? You should get R by 3. And what is R by 3 is D by 6. Now this is very funny. See this value. Is it A by 6? This one is D by 6 and this one is also D by 6. So very easy to remember. For standard figures is always, suppose I say that this surface is insulated. If this surface is insulated, will it be 2 or will it be simply 1? Then you will not get D by 6. So when you are getting D by 6, when all the surface are convecting the heat. If any one surface will not participate, your standard value will not obtain. What type of question is expected? Question expected is like this. They will give all these dimensions. That is the cube is given. They will provide you the value of cm. They will give the value of either k. Km is also sometimes represented by cm. C for constant. M for mold constant. So if I provide you the dimension of this cube, if I provide you the dimension of cube 50 mm, 50 mm, 50 mm, and I give the value of cm. So can you find out TST? So you can have 4 different types of questions based on this. That is the basic question. Then as far as gate pattern is there, what they will say? They will say that if this drop is reduced half, is okay. The drop size of this one is reduced by half or is multiplied, increased by 2 times. Can you find out the change in the constant? TST time का percentage change हम निकाल पाएंगे? So that is the relative comparison concept. Or what the question is? They will say that there is a one casting like a cubicle and one casting like sphere. They both have either same surface area or either they have the same volume. One of the condition is given to you. If they say that they have same surface area, then is 6a square must equal to 4 pi r square. Then do you have fixed relation between a and r? And then they will ask you what is the TST ratio for cube to sphere. Or they can put up the question like this, that this casting and this casting, that is spherical and cubical, has the same volume. Even they have same volume, we have a cube here and 4 by 3 pi r cube. So can we get a relation between a and r here? What I want to say is that indirect hint is given to you for the relation between this value and this value. That is a with r or a with h, something like this. And they can ask you relative comparison of 2 objects. So this type of 4 or 5 types of questions are expected in Chvorinov rule. Once we finish the Chvorinov rule, we have a total idea of what? Solidification time. Then we can go for riser design.